love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make him known. So welcome to the Math Map. This is Lee Bortons. I'm here with our co-host, Kirsty Gilpin. Today is Wednesday, October 4th, 2023. I can't believe how fast the year is going. And we're here to help those who both love math and don't love math to enjoy making the unfamiliar become familiar. And so thank you, Club, for being here.
And thank you, Lee, for being here. You've been traveling, and so we appreciate you. Oh, nope, don't play it again. All right, this week we're on lesson 22, which is populations. And so we're going to go ahead and take a look at this beautiful picture. And it says at the top, the manner how the whole earth was peopled by Noah and his descendants after the flood. And so I won't read any more unless somebody needs me to. But what do you think about that piece of art as representing populations?
I am curious what's happening on the left side, because I've seen this before. I can see the middle is like a family tree of people, and the right side is the animals from the ark. But what's happening on the left?
I mean, I think it's the Tower of Babylon. It's showing the pagans also, not just the Hebrew family and pre-Hebrew with Noah's Ark. But I could be wrong. Does anybody else know?
That's what I've always thought it to be as well.
It says Armenia underneath. Oh, I just noticed that the root is actually the ark. And you got the rainbow from the far right.
Was Mount Ararat in present-day Armenia?
I think so.
It's
because the boats. Okay, the trees on the boat on the Armenian mountain.
right.
Interesting.
I just saw the ark that you were talking about. I was like, where is she seeing the ark? Okay, I finally see the ark. Okay.
The ark is not the way Noah built it, though.
No.
When you read the description, it did not look like that. Just saying.
The house part looks like a log cabin era American colonial home.
Yes.
Yeah.
Lots of windows.
Well, the other thing is with this Babylonian thing is what I think it is on the left. Are those nooses for lynching people, or are they pulleys for building?
I'm going to go with pulleys, I think.
I got a little dark there.
Yeah, let's go with pulleys.
Because they have a horse and a llama. So yeah, so they're pulling things. And there's nobody really at the top working. So they're building, they're going upwards. There's a couple people.
I think it's interesting that the sun has a face.
Yes.
Mm-hmm.
I wonder what that would symbolize.
I wondered if it had to do with something like the pagans worshiping the gods and trying to reach the gods.
Mm-hmm.
Or in their version, thinking the sun was a god.
Which is like, I would never, in my worldview, contrast the sun with the rainbow. But maybe that's really meaningful, the sun god versus the covenant promise.
I think it's really interesting because it looks like it would have been, it was published in London. So it was, European publication, but if you look at the tree, Asia is in the center, and Europe and Africa are the side branches,
Mhm.
right? Which theologically makes sense. But I just think it's interesting that the author, right, in a time where so much was Europe centric, right, didn't do that here, but portrayed it otherwise, right? So there's a great conversation you could have with kids about geography and
So it's such a good representation of populations though, because you have animal populations, a single family population, and then a whole village of populated people.
we could
And
probably
even-
talk about this for a long time.
Even the sky's populated with birds.
I think it's unusual too, to me, that seems like timelines usually move from left to right, but they have almost moving right to left across the art.
Do you think it's because the pagans versus the promise and the family that's gonna be the bridge between the two is in the middle?
Wow.
Ooh, yeah, in the middle, almost like your initials, how you have your first name, your middle name, and your last name in a giant in the center of monograms.
The family matters. Oh, I know why. Babylon, the Tower of Babel and all the evil stuff is what caused the flood. So from that point of view, it'd be left or right.
Well, I was thinking too,
Well,
it's ironic, it's kind of ironic that the flood was to cleanse the earth, but yet here's man going right back to their selfish ideas again.
but I thought, and I could be wrong, I'm trying to work out my timeline, but I thought the Tower of Babel happened after because that's when the languages were separated. So only Noah's family was alive after the flood. And then they built the tower because Ham, Shem, and Japheth, the son of Ham, Nimrod, with the tower and then languages.
Mm-hmm.
Yeah, if it actually is the Tower of Babel, I was thinking it might represent like the whole Cain and Lamech time period where people were just evil. But it could be
Well,
that.
that's
I
true.
don't know. I don't know what it is. So that'd be a
could
good
be.
thing for the students to research.
Well,
Right.
it's also interesting if you think about, it says 1749 on there, that if you think about that period of time in England, that the history at that point was, right, we're in that industrial revolution sort of period where people were leaving the land, they were leaving the farms and coming into the cities, and that urbanization began. And even here in the US, right, it happened a little bit later, but that juxtaposition or contrast between the farming and rural life and the urban life, this makes you feel like it's always been maybe a little bit of a battle between the two, right? The idea that those cities, right, bring out the worst in us somehow.
Well, in that case, Europe is on the city side and Africa, which is today even still rural, is on the right side by the Africa animals. I mean, by the ark animals. This is such a great picture.
Well, we could talk about it all day, but we do have other things to talk about. So I'm going to go ahead and click to our next slide because we have good things to talk about there too. All right, so this week, as we look at the math map and we think about the language and order of mathematics, I just want to highlight for you. I apologize for how slow my computer is working this. But I didn't want you to change slides. Oh, you didn't. Okay. So as we look at this over here, we have numeracy at the beginning, and then arithmetic, and then geometry, and then astronomy and harmonics and imagination. And I really want to just take a minute to highlight. You may never see these highlights because my computer's struggling. But I'm trying to highlight these blue bars. That's really what I want to draw your attention to there. And talk a little bit about the trivium and the quadrivium. And so you've heard us talk a lot about the language of mathematics. How does that go together with the idea that the trivium is really a study of language?
Can you clarify your question some, Christine?
Sure. So when we keep talking about how one of the focuses of the math map is on the language of mathematics, and then think about what we are really doing when we're in CC and our children are still in our home schools. What are the arts that we're focusing on? Right. We talk about the trivium being a study of language. Right. Does that mesh well, or how do those two ideas go together, that we're emphasizing the trivium at the same time we're emphasizing understanding the
Quadrivium.
the language of math and the trivium? How does that go together? And what might that tell us if you want to think about the next question as we look at these things, that the arithmetic, geometry, harmonics, right? That's the quadrivium. Are we quite there yet?
So the trivium actually it's got dual purpose. There's the trivium that we talk about the most in CC, and that's how to learn. You learn the grammar, you wrestle with it, and you become rhetorical. Then there's the trivium that is the grammar, logic, and reasoning. And that is more, and that's what we're doing in here. We're talking about the grammar and the language and how it's logical, and it's more, and it is more that, language of mathematics rather than, it's rhetorical to do problems and to answer problems and to write your own problems and word problems and things like that. So I think the trivium in doing the math map is that we really are getting to the basics of the language of math, and we're looking at it like a language. So we're looking at the grammar, we're looking at the logic of it.
Right, because you really can't get to those more advanced ideas. You can't talk about them if you don't have the language.
Yeah, it's hard to say why an intersected shape might be a geometric study if you don't know what intersected shapes or geometry means. And it might be that you actually do have meanings in your head for what they are. But when we're coming together as someone painting a picture versus trying to solve a math problem versus developing a CAD program, we might need some clarity to those words to be sure we really know what the other person is saying. So you always have the context of what conversation you're having, that even though you might have a basic definition of the words.
Yeah, Lee, I remember you saying one time, something I listened to was, if your child's struggling with something, you need to determine, is this a grammar problem? Do they not have the words? Or is it dialectic? Do they not know how to work with what they've got? Or is it anyway? And I feel like if we don't give our kids a good basic understanding of the language of mathematics, we can't even determine where the problem is, because it might not, you have to start with the grammar, but maybe they do have maybe they have an understanding of the concept, but if they can't put it into words, they're not going to be able to teach it to someone else. And it limits their ability to go farther with anything.
I wonder if Americans not being bilingual causes a lot of problems, because this reminds me of a conversation I had in South Africa with the CC families. And unlike the American families, they didn't want to rush their 12-year-olds into the challenge program. They actually wanted to make a rule that they had to be older to go into challenge, because since they knew their children were going to be bilingual, they wanted an extra year knowing their own language before they started to move into English and their native tongue. Because they understood that language was the foundation of everything else you're going to learn, especially if you're learning a new language. And the reality is math is a new language. And if you've never welded before, welding's a new language. Like everything is a new language that you've not studied before. So that's why the Trivium is so foundational to moving on, like you said, Gianna, into anything else.
I know that's given me a lot of rest to think that my job in our homeschool, emphasizing the Trivium, is to really emphasize that my children have a solid grasp of the language of mathematics. And it's okay if they are not rhetorical in arithmetic or geometry or astronomy or harmonics, because that's the quadrivium and that's the next stage of learning. And so I want to really set them up well for that next stage of learning, which doesn't mean we don't study advanced ideas or work through things, because as Babs points out, right, there's a lot that a lot of exercises and problems we can solve without being rhetorical. But it really, as Lee emphasized, right, it's so important that our kids get that language first before we push them into really going deep with the quadrivium. And
Kirsty,
so
I think what you just said is super helpful for explaining the two. You opened up with what you just said with saying, what is the grammar of arithmetic? And I think that's what we have to start saying. So what's the grammar, the dialectic, and the rhetoric of arithmetic? What's the grammar, the dialectic, and rhetoric of geometry? Just like we do for major categories of thought. And then we can start to see, oh, the arithmetic has those, but it's not those.
yes.
So would you say that the same thing kind of applies to Latin, for example? Like we learn the grammar, we learn the dialectic, and we get a little rhetorical with Latin. But in the end, at the end of CC, we're really just walking away with the grammar of language. Okay.
You know, it's just like Donna said, when we actually explain, you can be 5th grade and explain how to add, and they are being rhetorical at that point. But the rhetoric is really, you know, it's like an inverted pyramid where it just gets more and more of all of it as you expand and expand your knowledge. And anytime you learn something new, it's like you shrink back to being a kindergartner and starting with the basics of the grammar, but then that just keeps rolling on as you accumulate language and accumulate mastery in things beyond language, which is kind of funny. I don't know if there is anything beyond language. I have to think about that.
Maybe what's beyond language are the results of language. And like God used language to create. And so there was the product of using language well.
There are unspeakable things that are beyond the scope of language, I think.
The Spirit intercedes for us with groanings too deep for words.
Yep. Unsearchable riches and unspeakable treasure. I forget that verse.
Maybe community, because community is built through language, can be torn down through language. I don't know. Well, that would hijack our entire day, so I'm going to move us along a little bit. As I said, I just wanted to point out, so we've talked a lot about the Trivium, but pointing towards that quadrivium, and that our goal as classical educators is to be practicing those arts, those liberal arts of grammar, dialectic, and rhetoric, to prepare our students for the liberal arts of the quadrivium, which are the arithmetic, geometry, astronomy, and harmonics. And so we want our students to be well prepared to go ahead and study those, which are all really mathematical, right? So when we think about harmonics and music, we're pointing out here that it has a mathematical underpinning, right? Astronomy, even though that's pointing to, in our modern understanding, sciences, right? It all comes back to mathematics. So we really want to point out here on the math map that we are preparing our students well for those studies of the quadrivium, right? That is what we're doing, is preparing our students well for the study of the quadrivium by giving them the grammar that they need for each of those liberal arts.
Yeah, let me add to just to see the integration. So when we're working through our debate strand and they're thinking about ethics and right and wrong and arguments, they're preparing for harmonics. And when we're going through research and our science, our research strand and looking at the way the world's created, they're being prepared for astronomy. That everything we do is going to get them to these 4 arts if they pay attention to it.
Those 4 arts are the beyond the rhetorical of math. And one of my favorite CC curriculums is Math in Motion and Challenge 3, because you truly see that connection of math and music. I've always known it, but I got to dive into it and it was awesome. And I would love to do that with our astronomy, and we do it in geometry just through our other math programs that we're doing now. But it's important to have that trivium solidly there before you get into geometry, because otherwise I'm just memorizing formulas and giving things away. It's not something that is worth, I don't have the words. I can't really do geometry. I hated geometry in high school, but I didn't have because it felt like formulas and I hated it.
All right, so we're gonna go ahead and dive in. Thank you, Donna. But I'm brokenhearted because I love geometry. So let's go ahead and dive into our conversation about populations. And I pulled up, when you eventually see the full curriculum, you're going to see that a lot of this week emphasizes the canons of rhetoric, the 5 common topics, that we're using in the dialectic, and also how we use names, right, to talk about mathematics. So the first 3 pages of the charts are really emphasizing the trivia and also the importance of arrangement and how that can help us in mathematics. Then the last page of the chart is, you're seeing a small sample here, is about statistics. And I just thought it'd be interesting just to recognize, I'm not going to read all of these scripture references, but how many times in the Bible, right, God talks about a census, whether it was a census of Israel or the Roman census, right? And we today still do a census. And so what, from your own understanding, what is a census?
Accounting.
Accounting of who?
People.
Depends who you want to do the census of. A U.S. census is a counting of the population of the people in the U.S. A census of the dogs in the shelter is a counting of the dogs in the shelter.
Right. It is a counting, and what the key thing we want to understand there is it is a counting of everyone in the population. And that's why
so the word census always means like all of it.
Yes.
Does it come from something like the root of century or 100% or cent? I'm trying to figure out why I didn't know that.
I don't know we should look at the etymology because I don't know. Yeah. But it does mean everybody, right? And so when God said, count the people of Israel, he literally meant count all the people, or count all the males that are right of age to fight. He meant go and literally count every single one. He didn't want an estimate. He didn't say, well, about how many priests are there, or go and see how many, if there's a couple of priests for each family. He said, no, go and count each and every priest, right? And so when the Romans wanted to do a census, how did they do it in Luke 2? And how did God use that?
Sent everyone to the town of their heritage.
right? Everybody had to go back. And so that made sure that we could now count all of the people, right? And so a census says, I'm going to count everybody. And so if you look at the top there, when we talk about our population, as Donna pointed out, our population can be different. So in those censuses, we had everyone sometimes, the military sometimes, priests sometimes. We can, whatever it is that we want to count or study is our population. We do a census in the United States still. And there's a lot of, it's interesting because every year that they do it, there's a lot of arguments that sampling would actually be more precise than the census. Because what happens? How many of you actually like spoke to a census worker personally? Did anybody talk to a census worker twice or get their paperwork to submit twice? Right? So it sounds great that we're going to go out and we're going to count all the people, but practically speaking, is it easy to do?
So are you saying doing it badly with the sampling plan is better than trying to get 100%?
Yes.
Interesting.
Statistically, if it was a random sample, statistically, mathematically, it would be a better estimate of the country's population and distribution than the actual census is of people that are going out and counting, because there's so many errors.
Is that because one demographic might be mostly skipped, and with a random, you get some of everyone?
Well, it to some degree that could be, right? So so yes, you're more likely to have skewed data. You might, right? So if you think about apartment buildings, and the census takes so long, right? So if you've got transient groups that are moving in and out and you're trying to count them, then yes, you are more likely, right? If somebody came and counted the people in our neighborhood, it's pretty easy because people move in and out, but not hundreds of people every day. And so they could go house to house and they could probably get a pretty close estimate as to how many people live in our neighborhood. But if I was to go into a large city where there are people living in the parks, there are people living in cars, there are people living in the subway, there are people living in apartments where they're maybe moving, right? Hundreds of people moving in and out. All of a sudden that becomes just prone to error. Whereas if I was to do a sample, right, and now I'm not trying to count everybody, I would still be counting a lot of people, but I would be able to look at that data and make sure that it is representative of what was going on. So yeah. So I could talk all day about this, and I'm going to really like work on reining myself in because it's already 1:30, but I love statistics. It's really interesting. I'm just going to throw this out there because it's not part of our curriculum, but you know, in case you're at a trivia, you know, it's the central limit theorem is the thing that says statistics are really going to give us a good estimate of our population. Notice that if I have a parameter, that's something that's true about my whole population. Statistics are something that's true about a sample. And then we talk about how close the two are going to be. And so down at the bottom right-hand corner, I use these ideas of 68%, 95%, or 99.9% confident that our sample is true for the population. So that's saying that's how confident we are that our statistic is equal to our parameter. Right. So if I asked everybody on this call how old they were and came up with the average age, that would be our parameter. If I then randomly chose 4 people that are on the call and ask them their age, I can mathematically tell you how confident I am that that sample, that statistic from that sample matches our parameter.
So like if you had 10 people and then you asked just 4, you'd be 40% confident?
No, it doesn't work quite that,
No? Okay,
that
not
way.
that easy?
Not that easy, but that's where standard deviation comes in. Because when we look at standard deviation, there's a formula for that, but it's basically saying what's kind of the average deviation away from the mean that all those ages are. And so if I have very nicely distributed data, then if I'm within 68% are going to be within 1 standard deviation, 95% are going to be within 2 standard deviations, and 99.9% are within 3. And so that's what when you hear people talking about those numbers and standard deviations, that's what they're saying is how confident they are that that statistic is the same as the parameter.
Okay, I got a question for you to look into. I'm almost interrupting you here, but you use the word parameters here, and it occurred to me that we also define it in lesson 2 of the math map. And I want to just make sure that we're saying the same thing, or are they 2 actually different meanings of the word?
They're really 2 different meanings of the word.
We can talk about it later. I just wanted to point that out to you.
Okay.
I hadn't asked that before.
So we're not going to spend a lot of time. I just want to point out that when we talk about sampling, sampling is how we choose those people from the population. And the gold standard is a random sample. And that just means that everybody has an equal chance of being selected. And there are different ways of getting a random sample. There's a few of them are there. The ones that we want to watch out for, though, are the convenience samples. And again, sometimes they can be done well, but if they're not, if it's self-selected, then usually our data doesn't tell us much about the bigger population, right? So if I was to ask everybody on this call, how do you feel about the math map? And you were like, it's amazing. That's a convenient sample, and your data is only going to tell me about the 10 people on this call. I can't say the 10 people on this call love the math map, therefore everybody in CC loves the math map. All right. So that's the thing that we kind of want to be asking ourselves, especially as consumers of information, when we hear people say, oh, well, this study, right? We always want to go, well, was that a random sample that you got, right? How was your sample selected? Because if you just went out and chose the people that were going to tell you what you wanted to hear, it's probably not good data. So, all right, I'll get off my hobby horse. We should have like a statistics only day where we just all get on and talk about statistics.
I'm in.
You can do that.
All right, just a reminder that we are building towards our launch of complex, the complete curriculum for complex next year. And when I say the complete curriculum, that means that people are going to be able to buy 30 booklets that have the art, a sample contribution to the conversation, a copy of the math map, framing pages that are going to help to put the lessons into context. They're going to have 16 lesson pages that are designed for 4 days in the week to complement the challenge program, along with 4 charts that are the scope of the curriculum. And so every year, every family is going to be able to see where their child is heading in each particular topic. A careful calculations page, which allows for practice of calculating within that topic, conversation starters for at home, games for on the go, games for at home, lots of different pieces packaged together in those 30 booklets. Those are going to be available for sale in the spring, and we're really excited about that. Alongside of that, we are going to begin releasing some of the narrower domains the narrower numerical domains are going to be released digitally first. And when we say that, those digital releases will be the lesson pages primarily, along with the solutions. I forgot that the solutions are also included in those booklets. So they are standalone. The digital releases will not have the framing pieces. They will not have the charts, but they will have the lesson pages and the art and the solutions for families who want to dive in early. And then we'll be rolling out more and more each successive year. And we're excited because we've got a couple of new flashcard decks coming. So that's going to be a great way to load that grammar. All right, so let's go ahead and spend the rest of our time talking about a page from the naturals. And Jana, I just wanted to say thank you for your testimonial. Jana said that she's been doing the naturals with her 12-year-old for 6 weeks, and they already have seen a huge difference in their ability to have a math conversation. So thank you for that testimony. That's great. So let's go ahead and have a math conversation. Looking at the top box, and if we read that, and here's a great example where reading is so important and not just diving into a problem. But if we read, let's look at the right-hand side. It says to trace the box and whisker plot for the ordered set. So as we read that, using our skills of language, what does that tell us about what is below?
A box and whiskers plot.
Okay. So it tells us that there's a box and whiskers plot. And what else does it tell us is there?
A gray line to trace.
It also says there's an ordered set.
Excellent. There's an ordered set. So which of those is the ordered set and which of those is the box and whisker plot?
It's a
The
good
set,
question.
the numbers and the letter and numbers is the set, and the box and whiskers plot is the picture.
Excellent. So how can a cat face help us to build our memoria?
It's cute. I'm gonna remember it.
Yeah, whisker plot. There's the whiskers.
I mean, yeah, I think when I took statistics, I think I had trouble with the whisker plot, but now seeing it with a cat face, I'm like, oh, it kind of makes sense to call it whiskers now.
If we wanted to understand this, what could we compare? Do you guys see what are some things we could compare between that ordered set and the box and whisker plot?
The numbers. And you've even got, like, I think it's hard to see, I'm on a phone, but like a box around the 3 and a circle around the 5 and a shaded box around the 9. So like, and so you've already kind of given that correlation with the extra kind of clues. But yeah, and where that is on the box and whiskers plot. 3 is whiskers, 5 is a box, and 9 is whiskers again.
Good. Do we need to know what all of those numbers mean at this point? Or is it just helpful to compare the numbers in the set and then the numbers on the plot itself?
I think it's enough just to compare. I don't need to know what it is. I can look and I can see that I think that's where those 5 common topic conversations really come in handy. We know that those numbers are part of the set. That's a definition, but then comparing what the set is versus how those numbers are in the plot and how they're drawn and what is it that's significant, and where is it that the picture is changing in the plotting and things like that. Just compare that to plotting a line from 3 to 9. What's the difference? What's the same? So yeah, you don't have to go beyond what they already know. You just push them to see what they don't see, or just immediately just by tracing.
Yeah, I was thinking this is a good example too of how it's universal, even though it's naturals, because I could take this lesson with a child who really easily could read these number lines, but say to them, why do you think the 5 got circled? And why is it lined up with the line next to the I? Might be because there's 2 of them. And all you're doing is seeing, you don't know why that is, but you're trying to see really what's in front of you.
Yeah, I was thinking about Jana with her 12-year-old, right? That there's all kinds of things that you could discuss here. Right, just the fact that this isn't symmetric, right? If we look up above, right, does our number set look symmetric, right? And as Lee pointed out, there's 2 5s. So how does that impact things? What does that tell us? So there's
I
a
mean,
lot of,
you
Go
can
ahead.
use what, I mean, I already know, like, that's a mean of that set. I think that's the mean. It's the one that occurs the most.
No,
So to me,
mode.
that's significant. Mode. Okay. But yeah, that's the one that occurs the most. So like, if you already have those words, mean, median, and mode, you could have that conversation.
Absolutely. That would be a great conversation with an older student, right? So if we're becoming rhetorical, recognizing that 5 is a mode, but when we're doing our box and whisker plot, what we're really interested in is that it's the median, it's the middle value, right? There's 3 to the left and there's 3 to the right. And so it's our middle value. It's also a mode, but it doesn't have to be. If that had been a 4, 5 would still be our median, right? If it was 3, 4, 4, 5, 5 would still be our median. And then our mean, right, would be our average. So that would be interesting to ask a more rhetorical student, where do you think that the mean is going to fall? Do you think the mean is going to fall between the 3 and the 5, or between the 5 and the 9? Right. Looking at this, where are there more values? Are there more values between 5 and 9, or are there more values between 3 and 5?
So what I said was actually coincidental that the 2 5s are the mode, but they line up at the mean. Right?
Yes.
And look, I'm not embarrassed or anything. It's really okay to be wrong. It's okay to start talking and noticing the pattern, because then when I get to another one and it doesn't match what I just said, I would go, huh? And I'd have a question.
But Lee, what you said wasn't wrong. It just, the conclusions you brought from it may have been wrong.
Yeah.
So yeah, but then it is. And I like how you told us the other day that it's the pages match up. So 2, 5, and so I could go look at the other ones that are also going to have this plot on it and compare and see if my conclusion that I thought yesterday, because the mode and the mean or the median are the same, is that the same in the next one, and I can figure out which one I'm actually looking for.
Yeah, and you just pointed out another advantage of the mapping is, so if you have 2 children, one in naturals and one in reals, you actually now have 8 problems you can go look at that'll be different, all about the same box and whisker, as well as what Kirsty's given you in the companion. So we continue, if you know how to be classical and compare, we have given you way more than you'll ever need to eventually get to the right conclusions.
All right, we are getting close on time, so I'm just going to tell you, right, that as you look at the middle there, when we look at different arrangements of data, right, that reading from that is integrating math and science in this case, right? It may be integrating other things, but this may be a case where we're integrating mathematics and science because we're being able to look at this arrangement. And then I'll let you ponder whether or not you ever make truly random choices, because we don't really have time to talk about that. But next week, we are going to be in the 4th dimension. So come prepared to let your mind stretch a little bit as we consider how can we study the 4th dimension using the mathematical tool of matrices. So that'll be fun to think about. as we do that next week, October the 11th. And so until then, think happy math thoughts, do the naturals.
Thank you.